Hello everyone, welcome and thanks for coming. As Patrick mentioned, my name is James Koch, Solutions Architect and Certified Software Tester for Quilmont. I've been using Appium for a few years now, and we've deployed our strategy to teams of all different kinds of scope. In this webinar, I'm going to explain to you what Appium is and how you can use it to leverage your test efforts. We'll cover the most efficient way to write your test plan and how you can organize your code to be more readable, reusable, and maintainable. I was recently featured on Joe Colantonio's podcast, Test Talks, where I gave an overview of some of these topics. Use this webinar as a resource to dive deeper into the main concepts and structure of Appium. I definitely recommend listening to my interview and the interview right before mine on this topic, which was with the creator of Appium, Dan Keeler. Let's begin. For starters, Appium at its heart is a web server that exposes a REST API. It uses JavaScript Object Notation, or JSON protocol, to communicate between your device, the Appium server, and your test code. You can think of JSON as the roadway or the power lines your code travels down to reach its destination and then return home. In this tutorial, our tests are kicked off in your IDE. The Appium server is responsible for communicating and sending any commands to our devices, and then it sends results back home in the form of a report. Appium manages its runs through sessions. Each time the server is started and a new test case is ran, a new session starts. After your tests are done, the session stops and your suite's complete. Appium's laid its philosophy out into four main principles. They achieve the first by using vendor-provided automation frameworks under the hood. This way, we don't need to recompile or add any Appium-specific or third-party code into your app, meaning you're testing the same application that you're shipping. I think this is a huge advantage that you can run tests on production release builds. They achieve the second by using client libraries written in all the most popular object-oriented scripting languages. They achieve the third by using Selenium and WebDriver protocol, which has been the standard for automating web browsers. I said, why do anything different for mobile? We'll come back to this topic later in the talk. Being that Appium is open source and free, I believe this is a great alternative to these large, expensive enterprise tools. This allows smaller teams and smaller development firms the capabilities to test your app in a more efficient and effective manner than they are today. So why choose Appium? It's to my last point exactly, I believe there's great incentive to use it. More and more firms are switching to Appium to automate their test cases. Appium is one of the most widely accepted open source automation tool on the market today. One of the biggest advantages is Appium's plugin ability. Sauce Labs has a great tool to run your tests on multiple real physical devices. AWS Device Farm and Keynote Studios also are great outlets to run your tests on these huge device pools. Between those three options, you can run your application's test on pretty much any device on the market today, without adding anything to your application to test it, unlike tools like Calabash. I was in a manual tester role once, and while every time there was a new release, we'd have to continue along the test plan, and then go back, retest what was already tested to make sure that the fixes didn't throw off what was already tested. Appium and its automated testing makes that tedious routine obsolete. Don't get me wrong, manual testing and beta testing is vital to the success of your product. And this type of testing is not meant to eliminate the two. It's meant to guarantee quality on production builds and to hold your developers accountable. I wanted to include this section so you can get a handle on Appium and not be overwhelmed when working with it. Every great development team knows that having an understanding of the software development lifecycle is critical to your app's success. Test-driven development is the process of verification as you develop. I believe that test-driven development is what separates Agile shops apart from their competition. This helps assure quality through the whole process of development. I included this quote on LinkedIn I saw the other day because I thought it was really applicable. Sometimes it's good to remember you're developing a tool or a solution that hopefully the public thinks is second to none. If you've already developed an app and you're trying to apply automation, it's always good to begin with exploratory testing. This means playing around with it, going into each page of your application and documenting any and all user interactions someone might have with a particular page. Again, don't be overwhelmed. By starting a spreadsheet and documenting each feature of your app, you'll create a test plan based off of requirements. This creates a huge permutation of actions. The more combinations you can think of to test, the higher efficiency of the regression your test plan will hope to achieve. Most people see things as A, B, C, D, and it's complete. But as a fractional function, that's 24 different combinations, 24 different ways you can test A, B, C, D. Hitting every combination proves to stakeholders your app is solid, efficient, and quality. Here's a list of the tools you'll need to follow along with my example. We'll just be working with Android, but for iOS you're going to need Xcode and command line tools. We'll be using IntelliJ Community Edition as our IDE. You'll obviously need Appium installed in either Android Studio or the Android standalone. This is what we're going to use to build the emulators that we pass the specifications for in our test suite and in the Appium GUI. TestNG is the annotation framework that we're going to use to run our tests. It was built on top of JUnit and gives us more comprehensive reports and capabilities. The client libraries we're using is Java, but remember, if you feel more comfortable with JavaScript, PHP, Python, Ruby, do whatever you feel comfortable with. We're using the Pandora app as the example. I've provided a link to where you can download it from. Lastly, we're using Selenium to drive our tests. If you're developing an iOS app, I recommend running your app through Xcode instruments before trying to run it through Appium. Apple has stricter policies when it comes to code signing and who can automate your application, so provisioning profiles for devices and developers have to be set up to work with it. But like I said, if you can run it through Xcode instruments, you're more than likely set up so you can run it through Appium no problem. The minimal software versions Appium works with is 7.0 and up for iOS, and Android 2.3 and up. So let's talk about Selenium. I put this in a section all of its own because of its importance. Like we said earlier, WebDriver has been the standard for automating web browsers. They said, why do anything different for mobile? Why reinvent the wheel? iOS driver and Android driver were built on top of WebDriver. They encompass all of the techniques that WebDriver does, but with more capabilities and more platform-specific commands. Now, Appium driver was built on top of that, which allows you to subclass iOS and Android elements as mobile elements. This makes your script a lot more robust and adds a lot of coverage. So we'll now be showing a live demonstration of Appium in action. You can download Appium right from their website, appium.io. Before we dive into the GUI, let's take a look at how our emulator is set up. My AVD's name is Emulator 3. It's a Nexus 5 device, and the target API platform is level 22. We've specified the CPU and skin. We've allocated memory, and all that's left to do is run it. Back in Appium, these are the exact capabilities I'm passing to the server. Also note that these capabilities will be the same ones we provide our test plan for a local run. So here is the Appium GUI. You can either run your test as an iOS or Android. That's how your session is started off with the launch key. For Android, you provide the path to your application, the app package, the main activity you wish to test, and obviously you're going to specify this particular device. Appium comes with a built-in inspector tool which gives you details into what developers assign objects resource ID, class name, or XPath to be. We'll use these elements and assign them to variables for us to work with. Using the inspector, you can install your app to the device. Let's take a look at some of the elements on the Pandora app. This is the main login screen. You can see all the buttons and text fields have unique identifiers. We'll use these in the page object model and assign these values to variables to work with repeatably. Now let's take a look at the page object model used to test the Pandora app. The page object model is the best way to organize your test cases. This gives you the ability to break down each page in your application, document all of the objects on it, and run all of the tests pertaining to that page. To start, set up a new Java project or Maven project. There's going to be two packages, one for pages, one for tests. The first class in the pages directory is called the driver page or base page. The driver page is where we instantiate the Appium driver. This page is abstract and can contain any methods used across all pages, like the constructor. Here we have a method used by AWS Device Farm to take screenshots at any point in your test. Also, this is where we create a page factory object. The page factory object is what we use to find and classify our objects. The first class in the test directory is called the test space. It's also abstract and contains any methods used across all of the tests. The methods we're going to use are getName, which tells us which page we're testing, setUpPage, which sets the driver capability, and test steps are methods used in that particular page. For example, in order to get to the home page and run those tests, we need to log in first using the login page. If this test fails, it won't fail on the actual method, it'll fail in the setup. Setup Appium invokes all the desired capabilities, the app package, the activities, and remember, these are the same ones that we set up in Appium. We also have a method to restart the app after each class so we can move on to the next page in the suite. We also have the after suite, which tears down Appium and completes the session. So back in the pages directory, let's take a look at the login page. For starters, we use the page factory object to find and classify all of the objects on that particular page and assign them to variables. Here's our constructor from earlier. The reason we use this technique is so if we need to ever make a change to an object, add an object, or make any changes or test methods, it's done in one place. This is where also we'll write any methods we can possibly think of to test that particular page. For the login example, we have one method that simply verifies all of the objects loaded correctly. We have another method that sends a failed login, and it verifies that the correct message appeared. We have another method that a successful login took place and it took you to the home page. These tests should correlate directly to your test plan I spoke about earlier in best practices. Here, take a look at mine. If you notice, these steps will match exactly, but just programmatically. Remember, this is just a sample, so if it was a full regression, we would have a method for forgot password and register for free. Back in the test directory, let's take a look at the login page tests and the home page tests. Here's where we work with those abstract methods. Note the test.ng annotation. Before the test, we set up the page. At the test tag, we use the page's object to call any methods you wish to test. If you don't want to test a particular method, just simply comment it out. Let's see this running in action. So to start, I launch the server, and I'm going to run this as just a test.ng test. Note, it does a scan for all of the objects and then sends the unsuccessful login. And then sends a successful login. Once all the methods have executed, your tests for that page are complete. Now let's take a look at the homepage test to see how we can work with a repeatable process. In the before test, we have the login page's object doing a successful login. This eliminates the need to repeat code. Simply use that method to set up your whole test. After the setup, it'll execute any of the homepage tests we specify at the test tag. Let's see this in action. Again, this technique makes your code a lot more maintainable and a lot more repeatable. Duplicate code is inefficient and ineffective. But yeah, let's see this in action. Okay, so it sets up the page with the login. Verifies that all of the page's objects for the home page have loaded correctly, and then creates a new station with my favorite band, the Red Hot Chili Peppers. One example I wanted to show you was the menu tray test. In the before test, we do a successful login, and then we use the homepage object menu tray icon to begin our test tag. You wouldn't want to include the menu tray icon in your actual test because this is a feature of the homepage. If the homepage menu icon for whatever reason didn't load, it would fail at the before test, so when you're debugging, you know exactly where to look. That's another thing that's great about the page object model. You have access to all the page's objects by instantiating that page in the setup page. Let's see this run in action. So for starters, we have the successful login. Then we have our home page menu tray icon, do a click. And now it's going to run our tests, check menu tray navigation for exceptions. The deployment technique you choose might be different from mine, but I just wanted to show you folks how easy it was to run these tests on multiple devices in parallel. Device Farm is great. All you need to do is run this simple Maven routine to zip your project up and get its dependencies. Now let's go on to Device Farm and work with its GUI. First, we specify the application we wish to test. Next, we add the dependencies jar. I set this up to run on an array of devices, all with different API levels to have good coverage. No, all you have to do is run it. I've already ran this suite, so I'm going to show you what the results look like. Here are some of the screenshots and some of the reports that it generates. Each individual page has a specific report. Also, you can see the report from the entire suite. Here's some graphical representations of the performance as well. So tools like this are excellent because we are able to run 5 tests in parallel, all on real physical devices. Personally, when I was manually testing, we had to dole out and pass out individual devices per teammates. And then once we switched, they would have to run the full regression again. Here, it's easy to have access to these devices at a low cost and run tests. In conclusion, Appium is a low-cost, effective way to test your application for quality. The page object model is the most effective way to leverage Appium. It makes writing and executing test methods more maintainable, reusable, and effective. There are plenty of free resources out there to help you get started. Sauce Labs has some great tutorials. I also write for softwaretestacademy.com, where I publish concise how-tos, so I would definitely recommend checking them out as well. Quilmont is actually hosting a virtual classroom that has interactive training material in the form of PDFs, videos, tests, and exercises. This can be a great tool for managers to get their people Appium proficient at a low cost of research and development. Thank you so much for attending our webinar. I hope it gave you some good insight and gave you a good overview on why you should use Appium. I'm now going to pass it over to Patrick, who's going to open up the floor for any questions.